Okay, what we were discussing error detection methods. Previous method that we studied, that was error bit, that was parity bit checking. And now in order to identify the exactly which byte has the error at which place, so we do the next method that is called parity blocks. So how we do, we add another parity byte. Let's see, we will see that in the next slide. We use both horizontal and vertical parity. We detect and locate the error position, that which bit has the error, and the intersection shows the incorrect bit, that which bit has exactly got changed. Error can be corrected and retransmitted then. Okay, now just imagine these are our 3 bytes that we have to transmit. They are not the byte, they are basically 4 bit data. So B1 is 4 bit 1011, B2 is 4 bit 1100, B3 is 4 bit 1001. Now the parity rule that is agreed between for the communication, let's suppose it is even parity for this example. Now we add the row parity. If we have the even parity, then obviously the number of ones in each of the row should be even. Right now 1011, there are odd number of ones, so we will need to add the parity bit as 1. If there were already even number of ones, suppose for example we had 2 ones here only, then we would have added the parity bit as 0. Now let's see in the next example, we already have 11100, so they are even, so the parity will be bit will be added as 0. This is the row parity. And there is another, in the next one there are double ones, so obviously the parity bit will be 0 here. So as even parity is agreed. Now what we do in this, we make it two-dimensional, means we add a column parity as well. You can see that these are basically 3 ones in the first column. There is one single one in the second column, single one in the third column, single 2 ones in the fourth column, and single one in the fifth column. What we do, so the parity bit for the column wise parity will be obviously the same as even parity. There are 3 ones, so our parity bit will be 1, so it became 4 ones. In the next there is another single one, so another parity bit will be 1. There is another single one, so obviously parity bit will be 1. Now in the fourth column there are 2 parity bit 1s, so obviously the parity bit will be 0, because there are already 2 number of ones. And in the fifth there are already uh, 2 number of single, there is single one, so the parity will be 1. So this is how we formed the parity column parity. Now if we send this block, then the block may be the block reached to the receiver, that may be different from this one, and then we will have to detect what error, where is the error exactly occurred. Row parity is equal to odd, means error row. If row parity, the parity agreed is even and the parity is odd, this means in the row there is an error. But if the column parity is odd, then obviously error in the column. And if we take the intersection of both these, then we get the exact bit position that has got changed. Okay, the conclusion, error location is equal to row I column j, bit corrected by flipping 0 1. Let's understand this in the next slide. Uh, Suppose this is our two-dimensional array. These are our bytes. These are our 8 bytes. See this example 1, it is given in the book. And these are our 9 bytes that have to be transferred. And now we have to locate which byte has the error. And there is the last one, that is basically our parity bit as the row parity bit. And in the last most we have the parity byte for the this whole is became a parity byte, but this is a parity bit for each column. Now let's see. Now imagine that even parity is agreed between these. So the parity is even, so the number of 4 bytes, 4 bits, and let's first check the row parity. There are 4 ones and 2 ones. So number of ones are 6. That is even. So obviously this parity is even. This is correct. This row is correct. And the second row, 1 1, and there are again 4 rows and 4 ones, and this one is added as a parity bit to complete these value. And next is byte 3. How many values are there? There's the parity bit added is 0. So there are already 6 ones. So obviously the number of ones are already even. So it is 0. And in the byte 4, there are 2 ones. So number of ones are 0. So we add the parity bit as 0. In the byte 5, we have 3 ones, and then one is added as a parity bit. And then in number 6, byte 6, 1, 2, and there are 2 ones. So the parity bit added is 0. So to maintain the even parity. And byte 7, there are 1, 2, 3, 4, 5, 6, 6 ones. So the uh, parity bit added is 1. And now just see the byte 8. In the byte 8, we have the parity bit is 0, and the rest of the data is 1. There are only 3 ones. So the number of ones are odd, that is 3. So obviously this byte has the error. Let's find out. This is the byte that is highlighted because this byte has an error. Let's see about the ninth byte. If it contains any error, no, it contains no errors as number of ones are 2. The even parity is agreed, so we have the parity bit as 0. And this is our parity. Now we are going to go for the parity, column parity. Let's count the number of ones in this column. 1, 2, 3, 4, 5. There are 4 bits as 1, 4 ones. So obviously the sixth parity bit will be 1 to complete the 6 bits as even number of bits. Now in the bit 2, we have how many? 1, 2, 3, and there are 3. Uh, and so obviously the parity bit will be 1. And next we have 1, 2, 3, 4, 4 ones. So obviously parity bit is 0. In the bit 4, we have 3 ones and 3, 3, 6. So the parity bit is also 1, and the total number of ones are become 6. And let's see about the bit 5. We have the 1 and we have the 5 ones. This means this contains an error as even parity is agreed. So we can't have 5 ones. We had to have 6 ones. So let's find out. Now we have to check which bit has been changed. So if we look at that, we can find out the byte 8 is changed. So and if we see it the column wise, obviously the intersection is basically this cell. Means in intersection we see the common cell or common uh, error row and column. So this is the row and column that contains the error. Byte-wise, this is the error. This is row contains an error, and column-wise, this bit contains an error. So this became the place of error. This bit is changed. Okay. Now we have to do the next. I'm sure everyone has understood that we have to do the 2 more examples to clear our concept even further. Let's see. This is the following. This is an example. This is an activity in the book. We have to see it row wise. So, but here the most important part is odd parity is agreed. If odd parity is agreed, this means number of ones in each row will be odd. So the first row has should be odd. If they are even, this means that byte contains an error. If you look at this, the number of ones are 3. So obviously this is fine. Here number of ones are, and the parity bit is 0. So here number of ones are 5 and 2, 7. We have added, they are basically 6, and the parity bit added is 1. So obviously it's fine. And 1, 2, 3. Their number of ones are 3, that is odd, and parity bit added is 0. That is basically row parity bit I am checking at the moment. And the byte 4, we have 3 and 4 ones. Okay, now just look at that. In this row contains an error. Byte 4 contains an error because we should mark it now. This byte has an error. Now we don't know at the moment that which column has an error. So now we have found out that this byte has an error. I'm not going to go for the further bytes. I'm just now going to check on the with the parity column parity. Two ones, 5 ones. That is fine. Then again, 1, 2, 3, and 2, 5 ones, 0 as a parity bit, that is also fine. Then 2, 3, 4, 5, 6 and 1 as a parity bit to make it odd, as the odd parity is agreed between them. Okay, sorry for this highlighting, that's a mistake. Okay, now let's see about the fourth bit. There are two ones, and obviously parity bit is one, so number of ones are five. So this way it has not no error, and this is three and two five. Again, no error because this one is completing the error bits, and this is the parity bit that is making it five. That is an odd number. And now look at bit six. One, two, three, and four. This means this has an error. This column has an error. So let's find out, and our byte 4 had an error, so we must now, okay, so this is the place of error. Now the common between row and column is the common cell is this one. So this bit has got changed, and that has become, if we make it 1, then obviously our problem will be resolved. So this is how, because if we make it 1, we will have in the row, we will have odd number of ones, and in the column, you will also have the odd number of ones. But at the moment, they are even. So this is why we have solved this problem. This is the bit that has got changed. And let's see which row, which column number, and which row number is that. Let's find out. So let's see. Wrong row is equal to byte 6 and the bit 7. Okay, it is calling it byte 6. No, no, it's not in that. This is, I think there is some mistake in this solution. Error at byte 6 and byte bit 7. Byte, basically, error is at bit 6 and byte 4. So this is a so byte 4 and bit 6 is the basically exact position. I don't have the pen at the moment, so this is why I just bear with it. Now you can see this is the error. This contains the error. I will fix the slide that contains the exact solution. So what we did, we just counted all those number of ones in the rows and the column wise, and checked the parity bit as well. So and we got our answer, that is byte 4 bit 6. Now this is another. Here it is mentioning that even parity is used again. So let's see about the even parity. In even parity, how many bytes there are? Basically 9 bytes, and the one is the parity byte. So let's see, number of ones should be even, and parity bit will be as 0 in the first byte, because the number of ones are already even, and in the second the number of ones are already even. There are 4 number of ones, so obviously this bit is 0. And in the byte 3 we have another even number of ones by adding the parity bit as 1. And in byte 4 we have another 1 to another, yes, that is also fine. 6 number of ones, and byte 5 we also have the 2 number of ones by adding the parity bit as 1. In byte 6 we have basically 1 2 3 4 5 6 6 number of ones, so that is also correct. In byte 7 we have 1 2 3 and 1 4, that is also correct. In byte 8 we have 1 2 and 3, so this row contains an error, byte 8. Now let's talk about the column parity. Now this is here, at the moment we were checking row parity. This is the basically column parity. Oh, one mistake that has happened from by me, that is, this is basically the parity bit. Obviously, this is the parity bit, not this one. I was mistaken in that at that. Obviously, it's written mentioned here, so I didn't read it. Sorry for that. And the parity bit is this one. My apologies. Now let's go for the column wise. In this, how many? 1, 2, 3, 4. So obviously number of ones are even, the parity bit will be 0. And here also number of ones are even, parity bit is 0. Here also number of ones are 2 and 3, 5. And so parity bit 1 has made the number of ones as even, that is also fine. 1 and 4, 5, and that is also fine because parity bit has made the number of ones as even. 1, 2, 3, and 4, that is also fine. Parity bit has made the number of ones as even number of ones, 4. And this is 3, 2, 3, 6. Number of ones are also even. This is 1, 2, 3. This